Thanks for joining us today. And today's session is Start Using AI ML DL in your .NET applications today. My name is Srilakshmi Pai. I'm a partner solution architect at AWS and focused on running Windows workloads. Over to you, Thor.
Hi, I'm Thor Giddings. I'm a senior solutions architect here with AWS, focused on the Microsoft platform. How many .NET developers do I have in the room? Get a hand? Awesome, I love it. How many data scientists? 0. Oh, okay, a couple. Okay, well, we won't kick you out. Don't worry about it. So this is really focused on using machine learning without needing all that deep data scientist knowledge, right? So let's get right into it. So here's a quote from Arthur Clarke: "Any sufficiently advanced technology is indistinguishable from magic." And this is a quote one of my previous employers liked to use. We had it plastered all over the walls. And I think it really comes into play when you're a .NET developer. Your boss expects that you will produce magic for them, right? So your corporation might have a goal to say, you know, we're going to infuse our applications with machine learning, with deep learning, right? They have that goal. But you might not have a data science team. You might not have people with those skills, but that doesn't change the goal. Well, today, I'm going to walk you through how to actually maybe achieve that goal starting right now. So the agenda, we'll walk you through artificial intelligence, machine learning, and deep learning to give you a background of kind of what that all looks like, that ecosystem. Then we're going to deep dive into some of the deep learning-based APIs that we have: Amazon Recognition, Amazon Lex, Amazon Comprehend, and Amazon Translate, and Amazon Poly. So getting straight into it. Artificial intelligence. So artificial intelligence is the capability of a machine to perform tasks that normally require human intelligence. And you see it's that outer bubble. And if you think of like the early chess games they had, like in the 90s, where you would program an algorithm to play chess, right? You're explicitly telling it, okay, here's how the pieces move, and it would play against you. When we talk about machine learning, that's a subset. So that's really where you're talking the ability to learn without being explicitly programmed. So this is something like price optimizations or intelligent restocking. And inside that bubble is the deep learning processes. So you're using neural networks or little neurons that are making inferences or predictions. And with that, you can think of maybe like computer vision and autonomous driving as a very popular space in there. So everyday uses of machine learning. We all have junk mail filters, and it's one of the cases where you want to be really accurate to figure out what is junk mail. The last thing you want to do is put a good message into a bin where no one's going to look at it. Also topic modeling and recommendations. So if you go to a streaming site and you watch something, it'll recommend other similar topics or similar programs for you. And then inside Amazon, .com's retail, we really pioneered the artificial intelligence field. In the early days, even in the 90s, we had recommendations. You'd buy a book, we would suggest other books. And back then, you know, things were done, there were a lot more humans in the loop, right? There were people taking spreadsheets and trying to figure this stuff out. And now it's much more, you know, machine automation. So when we talk about learning, there's really two broad categories. You have supervised and unsupervised. On the left, you see supervised. So you're talking about a data set with the right answers. So an example of this is classification. So if you had a bunch of different fruits, right, each one has a label. So you could say, okay, I have apples, I have pears, I have bananas. And based on the attributes of the fruit, you might be able to predict what type of fruit it is. But there's a right answer there, right? Same thing with regression. You could have a continuous quantity where you're actually looking for maybe a best price of something. You can actually optimize the price. On the right, you have unsupervised learning. So the right answers are really unknown. You could do things like clustering. So you see like news sites on the internet where they cluster stories together and you have the various news outlets. That's a good example of unsupervised learning. Also, it's used in network analysis. So the end-to-end machine learning process, if you were going to build your own model and really do this by hand and go through all of that work, here is the flywheel, it's like, as we like to call it. So the first thing you have to do is you have to access your data. You have to get your data into your environment so that you can use and prepare your model. Once you get the data, you have to clean it. And this is absolutely critical if you're building your own system. The cleaner the data, the better the predictions, the better chance you have of having a good model. And then you go into model training. And if you're going to do this, usually you set aside some data. You take 80%, you run it, and you train your model, right? You pick the best model, and then you take that remaining 20% to do an evaluation. You already know the right answer at that point, and you're running it against the model to see how accurate that model is. The next thing you do is deploy it so you can actually consume the model and make some predictions. But then you're constantly monitoring and augmenting that data, right? So you want it to constantly have a good ability to make good predictions. And that's just a constant loop. And in the middle here, we have Amazon SageMaker. That's our managed platform where you can bring your own data, bring your own code, maybe use some of our models, our algorithms, and build your own custom models. The good news is that's not what we're talking about necessarily using today. That's much lower level. What we're using today is a much higher level API. So let's talk a little bit about the AWS ML stack. At the very bottom, you have the frameworks and infrastructure. You have things like TensorFlow, MXNet, and PyTorch. You have interfaces like Gluon and Keras, and all the different infrastructure optimizations that were talked about this morning around ML. So if you're a data scientist, those are probably very interesting to you, but if you're a .NET developer, you've probably never heard of that, and that's okay, because we'll show you how to use deep learning today in .NET, starting right now. The middle, you have that managed services layer, which is Amazon SageMaker, we just talked about. And then the top level is what we're focusing on today. So we have different AI services based on what you want to do. If you want to do vision or speech or language, chatbots, forecasting, or recommendations. So we're going to deep dive on some of those. They use similar principles. They're deep learning-based APIs. And the nice thing is you just bring the data that you want to do predictions on. You don't have to build a model. You don't have to bring a whole bunch of data in to do really complex things like natural language recognition. You're using the model that's pre-trained. So let's get into recognition. So recognition is doing predictions based on images and video. And why is this important to enterprises, right? Well, there's an explosion of images, even in the enterprise space. But if you think about everyone's walking around with a camera these days, and you have all these IoT devices, and a lot of those have cameras, and the amount of images and videos that are infiltrating our world is just exploding, right? So what can you do with recognition? And when I think of images, I think of really unstructured data, right? You might have a folder or a CMS that's just filled with a bunch of files, but you have no idea what those files have in them. So what if you wanted to take your corporate assets and say, okay, give me all the pictures that we have that have horses in them? How would you do it? Maybe hire a bunch of interns and have them go through every single picture, and then, okay, give me the one with all the cows. Okay, and repeat until all your interns quit, and then you have to hire new ones, right? That's not a good thing for anyone. So with recognition, you can do object and scene detection. So you can see on the left, it detects a bicycle and a person, and actually puts those two together and says, that person's probably a cyclist. He's on a bicycle. Also, it shows the path and the mountains, and it gives a confidence rating of each of those objects. Then you have facial analysis. So it can actually break down the pieces of the face to say, oh, is this person smiling? Are they happy? Are their eyes open? Are they wearing glasses? You can do facial comparison, so comparing one face to another. And then finally, you can do facial recognition. So we'll double click on a couple of these. So when we talk about use cases, think about a retail environment. You could have an application that has a video camera inside your store, and you could collect customer sentiment analysis as they're in your store. And you could say, okay, what makes my customers happy? What makes them maybe stay longer in the store and buy more stuff? You could use recognition to actually detect their faces and their sentiment, and then put it into maybe an intelligent data warehouse like Redshift, and then use a BI tool to actually search out the data and optimize your store. Also, A/B analysis. So looking at your actual customers coming into your store and saying, okay, what should I target? Let's say I sell razors and glasses, right? So who should I sell what? You see person A is very well dressed. Maybe sell him a razor, that makes sense. And person B has eyeglasses. Maybe they would like a new set of eyeglasses, right? So you can do that sort of stuff on the fly. So facial recognition, it's kind of interesting. We actually collect what's called a face ID. So we'll break down the facial components that are in a picture and then store them as a face ID. And one of the really, really great executions of this is a nonprofit called Thorn. They use this to prevent the spread of child sexual abuse materials and child traffickers. They've used this technology to identify 5,894 trafficking victims, rescuing 103 children where their abuse was being recorded and distributed. So I think that's a really great use case for recognition, especially in that nonprofit space where people really need the help. And they may not have the underlying technology to make that happen. They may not have the data scientists. But with this, all you have to do is make an API call. So a couple of examples that you might infuse your applications with. So photo sharing apps. So if you have an application that's very social, right, and you want to build in maybe a photo sharing app, you can go in and you can collect all the different pictures where people show up and make a collection. Also, entertainment and news outlets. They're looking at their old footage and finding where celebrities exist inside of their old footage to bring those stories back to light. Secure campuses and workplaces, you could do real-time scanning of the people walking down the, certain corridors, and if they're not allowed to be there, alert people, right? And then public safety teams can leverage recognition to automate tracking persons of interest. So that was still images. We actually do video too. So you can do real-time analysis of streaming video where you're doing person identification and pathing, face recognition, facial analysis, object scene and activities detection, inappropriate video detection, and celebrity recognition. So let's just double click on inappropriate video detection because I think that's something that's very, very different at AWS. So what we do is inappropriate is different. It's different among industries. It's different among cultures, among geographies. So we're never just going to say, yes, this is inappropriate, or no, it's not. What we're going to do is give you the types of content and a rating. And maybe if you allowed customers to upload videos into your site, maybe you say, okay, if it doesn't have any of that content, just let them post it. That's totally cool. But maybe if they have some maybe questionable material, you put it through a manual review process to make sure that you want that stuff on your site. And if it's truly horrific stuff, if it's scoring really high, maybe you just throw that video right away and never even have a person look at it. So it's really an interesting way. And you'll see this with the algorithms where they give you a confidence rating of the prediction. So with Amazon Recognition, it's a fully managed deep learning based. So this isn't open source software. This isn't machine based. This is deep learning based. So it's at that very core of AI, ML, and DL. We have NuGet packages to consume it. It's pay as you go. It integrates with a bunch of other AWS services like S3, Lex, and Poly. And it's available in a bunch of different regions. So I'm going to do a quick demo. So just give me a second here. Okay, so what we're going to do is this picture. This is a pretty tough picture, right? You got people, but you also have a bunch of hands. And I'm just going to do a detect faces on this. What the code will do is it'll detect the faces and then draw a rectangle around that, right? So imagine if you had to program that, it'd be pretty tough. Well, let's see what it actually takes. So with this, you'll see the AWS Visual Studio Toolkit on the left. That gives me access to the most common AWS services, so I don't have to log into the console to access those. It also gives me a IAM role and a profile, so I can use this without having to embed access keys, secret access keys. And you'll see how easy it is. So in here, here's my NuGet package for recognition. So I have AWS SDK.core and AWS SDK.recognition. I create the client. I create the detect faces request. I read in the image data. And then I call detect faces. Now, it's going to actually return the faces and the bounding boxes around the faces. So I'm going to go ahead and draw a white line around each face that it detected. and then I'm going to show the picture. So you can see it's a couple dozen lines total, and actually doing the prediction is about a dozen lines of code. So if I run this, and it's running across the Wi-Fi here. It's nothing special, so it could fail. We'll see. You know, if you came to see something fail, it's possible. OK, it was that quick. It shot that image up, and if you look, it actually does an interesting thing. Like, it'll actually find where it thinks the face actually is, even in these partial faces. It does a pretty amazing job to actually detect all those faces. I could have used it today, take a picture of you to see how many people were in the audience. But you can imagine how easy that is to infuse that into your application. So with that, sorry, I will put you back on.
Thank you, Thor. So oftentimes when we build chatbots, right, or when we propose the idea of chatbots, it's relegated to something like, oh, it's a science project. You're saying that it will do this, but it's not really going to work, right? So first of all, in this day and age, thinking about science project as a bad thing is terrible. But most importantly, you can actually see how these chatbots, you have to look at, you have to focus on how these chatbots can improve your customer experience, how you can improve their interactions with your applications. So Amazon Lex is a service for building conversational interfaces using voice and text. OK, that's a mouthful. So what it actually means is you have a chatbot, and you're talking to it in your own language. That means in your own choice of words, rather than using certain texts or words that you're trained to use or click on buttons. So let's go back to basics, right? So you're using a kiosk or an ATM machine or an insurance provider website or something. So when you're using that and when you want to get through that particular task, you have to think like an ATM machine or a kiosk or that bank, right? But the hope with chatbots is that you get to think like you. The benefit is that you get to use your own language. By language, I mean your own choice of words. So you could just, if at all you want to check your flight change or gate change, you would probably have to go to a bunch of screens, click on some things, and then check it, right? But with bots, you could just go and ask, like, did something change with my flight? Or you could say something like, did I get bumped? Instead of, did I get an upgrade? So you could use your own language and your own choice of words. That's Amazon Lex. So there has been a natural evolution in the interfaces that all our machines use, right? So the first generation, the early days, it's punch cards and memory registers. I'm not going to ask anybody in the audience if they've ever used a punch card. That's not a question. I was not there when I didn't grow up with punch cards or memory registers. They were really labor intensive, and they were not that fast. They had a lot of manual tasks. But later then came the graphical user interface that I think most of us grew up with, right? It was actually amazing when first I used Windows desktop, right? I used MS-DOS as well. And then I've moved to Windows desktop. It was like, oh my God, I could use all these pointers. I could open up directories, files. I could create a paint. In MS Paint, I could create an image. And that itself was like, wow, for me then. And recently, I got to use, I got to experience that wow experience again with Amazon Echo. So when I spoke to Alexa and asked her like simple things like, what's the weather, or something very simple, there's something magical, to get that response back in real time. So it's like you're talking to Starship Enterprise, and you get these responses back in real time. But it's not that easy to develop these chatbots, right? All these conversational interfaces, they combine a large number of sophisticated algorithms and technologies. Each one of these items that you see here, if you start learning them, they'll quickly get overwhelming. Just tackling natural language understanding would take a lifetime of work. So the expectation with these abstracted services like Lex is that, your developers need not understand the deep learning neural network. They just get to use all these APIs that are based on those neural networks. And what do we shoot with a chatbot, right? What is the expectation? So it has to be natural. So even though it's a chatbot, you would not want to hear a robotic voice, or you would not want a conversation which is like a robot. You would want to talk to it and have that natural conversational flow. So that's very important, to have that natural conversation. And it has to be on demand and in real time. So if I ask Alexa about weather now, and if she gives me a response in an hour or even in a day, it will not make any sense. It will not be important. So it has to be on demand and in real time. And one of the most important and the most interesting part is accessibility. So one of the AWS user groups in Dublin, right, they wanted to illustrate how revolutionary these conversational interfaces are. So what they did was they got a person who was visually impaired, almost blind, he had not used all these applications that we use and we take for granted. Imagine not being able to use Google, right? So after getting this chatbot and working with that chatbot for a few hours, he had access to all this information at his fingertips and all these services that he did not have access to previously. So that's literally transforming, right? And it's a big deal. So all these traditionally excluded segments have access to all this information and services now. And also, commercially, also enterprises, it's a big deal because you can tap into these market segments that you did not have access to. For example, kids. How many of our kids ask to Alexa to play a song on Spotify? So you get to use Spotify, so kids get to use Spotify, and all these enterprises can tap into those new market segments that they did not have access to. And it's super efficient. You just have to use the API integrated into your application and build a chatbot and start using it. And Amazon Lex checks all those things, what we just spoke about. So first, deployment. It's super easy. You build a bot, and you just click on publish. It's just one-click deployment. You publish, and you can publish it to various channels like Facebook, Twilio, or if you have a Slack channel, you could publish it to that. Or if you have a custom bot, right, or custom client for your bot, you can publish it on that as well. So it's up to you. It's super easy. You can easily integrate it with DevOps, and you can start using your chatbot. And it scales, like all other managed services that we have, it scales on demand. And also, when you build these chatbots, if you want to build a sophisticated chatbot, you would integrate it with Lambda functions, which will actually call your APIs or call DynamoDB and do the actual work, right? So when you call Lambda functions, again, they can scale based on demand. You don't have to worry about any of the servers, infrastructure, or anything like that. It scales, and you just have to focus on business logic. And it's super secure. You can encrypt data in transit and rest. And also, you can add an extra layer of authentication using Amazon Cognito. So if you want to have your users log in before using chatbot, you can use Amazon Cognito as well. It easily integrates with Lex. And next is analytics. And analytics is very interesting. So you monitor your chatbot. You check what are the missed utterances, what are the most used utterances, what are the utterances that were not addressed by your chatbot, right? So then you can focus on what you need to build, what your customers are looking for. And also, you can check if your customers are using the bot for what it is not intended to do. For example, one of our customers shared this story. So they built a business productivity bot, an employee center bot where you would reset password and all those things. And that bot, when they released it to their employees, they started using, and they checked their analytics report. And one of the most missed utterances was, "Tell me a joke." So that bot was not supposed to do "tell me a joke," but still people kept asking the bot. And finally, developers had to add that utterance, a response to that utterance, "Tell me a joke," like, "Why don't you get back to your work?" So that's analytics. It gives you an insight into what people are looking for, and you can build around that. And Lex can be easily integrated with Poly, so you can have your bot talk back to you in different languages or different voices that Poly supports. And speech to intent, that's speech recognition plus natural language understanding, which is integrated into our Lex API. And I'm going to talk more about that in a second. And Lex also does dialogue management, that is, it maintains the context. Context is super important. So if you're having a conversation, it understands. For example, I'm having a conversation like, I want to know the weather of New York City, and it tells you the weather, and then you can ask like, is there a hotel available there? So you need not type in again, is there a hotel available in New York City? So it maintains that context for you. Some of the features of Lex, again, it is based on the same technology as Alexa, so you get all those benefits that Alexa developers get. And once you build this chatbot, you can deploy it into multiple channels, multiple platforms, which we support, like Facebook, Twilio, Slack, your custom bot. We've got multiple channels that it supports. And it is designed for builders. So any Amazon service, I think you should know that it's super efficient. It gives you an API, and you get to build and start using it automatically. Thank you. And all these API, Amazon Lex is enterprise ready. So you can connect your enterprise systems via SaaS connectors. And it also supports versioning and alias so that you can have multiple versions targeted different environments, and you can put it out there. And these neural network-based services, right, they're continuously learning. So you need not upgrade or update or anything. They're continuously learning behind the scenes and improving, and you don't have to pay for that. These are some of the use cases that Lex can be used. I'm not going to go through all of that. So usually customers start with employee center bots where, all these monotonous work that you do in your office, like password reset, for example. You could build a bot for that. So just think about all those tasks and see how you can automate it using a bot. And the interesting chatbots are like contact center chatbots, where you can have these contact center chatbots do all these non-value add tasks like getting frequent flyer number or something before you put a human in front of that person, right? So you can have this as a pre-task, or actually your chatbots can do the task, or it can do post-task, like it can just collect survey details. So you decide like where you want your chatbot and what tasks you want to perform with chatbots. You can have enterprise productivity chatbots where you will build, for example, reports with chatbots, and you're not dependent on a person. So if you're sitting in a board meeting and somebody asks for data which is not there in your report, instead of going back to the intern who actually developed that report, you just ask the bot to generate that report for you. So how does Lex work, right? So Lex has two parts to it, two sides to it. First is speech recognition. So speech recognition is nothing but what you said in what sequence. So I want to book a hotel, you say that. So speech recognition will recognize, I want to book a hotel in New York City, or something like that. And natural language understanding is nothing but it has to unpack that intent. For example, instead of saying, I want to book a hotel, I could say, can you please look for a hotel in New York City for me, please? And there are thousands and millions of ways human beings say the same thing, right, in multiple ways. But your bot or your natural language understanding unpacks that intent for you, which is, I want to book a hotel. So I could say, I want to book a hotel in New York City next week from Monday to Thursday, and my budget is $600. So my natural language understanding should unpack that intent, which is I want to book a hotel, and also extract the pertinent data which I have given. That is New York City, check-in date, check-out date, that is Monday, Thursday, and my budget, which is $700 or $600. So based on that, once you have all those slots filled in, your city, check-in, check-out date, and other extra slots that you have, you pass it on to a Lambda function or any other task, fulfillment task that you have. So the Lambda function probably will check the hotels in New York City and see if it's available with that budget, and it will process that. If it doesn't find something, or if it doesn't find a slot filled, for example, you did not give a city for the bot, it would again go back to you and ask, what city do you want me to book it in? And once it has everything, it will say, OK, I can't find a hotel next week for this budget. Can you increase the budget? Or can you change the date? So it can come back to you with all these suggestions, and once everything's fine, it can confirm the booking, and you can use Poly as well to respond back. So that's how natural language understanding works, where deep learning neural network unpacks the intent and extracts all the important information from what you have set. So Amazon Lex is, again, fully managed deep learning based system. And again, you have to just add a NuGet package for Lex in your .NET application in a Lambda function and start using all the APIs and send the response back to the chatbot. Again, pay as you go. You don't have to pay for any idle resources, and scalable and low cost. And currently, it's available in 4 regions: Ireland, North Virginia, and 3 regions, Oregon regions. Let's quickly move on to the demo of Lex. So this is the AWS console, right? So you go and check for Lex. And we have already few of the bots created, and I'm going to explain order flowers for you. And you can check here what are the regions Lex supports: Virginia, Oregon, Sydney, and Ireland. So it's total 4 now. So we've built this chatbot, order flowers. In fact, when you start building chatbots, there are certain blueprints available for you, like order flowers, schedule an appointment, book a trip. So you can start from there instead of starting from scratch, or you could start from scratch as well. So, and these are the sample utterances that we have. So when do people usually ask for flowers, right? When they have screwed up, especially guys. So we have an utterance like I screwed up. So if you type in I screwed up, it will probably tell you what flowers do you want to order. So you can have any of these utterances here. It's up to you. You decide on what utterances you want people to use. And then you have slots. As I said, you can have slots to get the data, flower type, and it can be a custom slot. So I can add a slot type here, flower types with different flowers, tulips, lilies, roses, or I can add multiple of them, And also I can have enumeration, like here the bot is learning. So even if you type tulip, it will understand it's tulips. Maybe not the first time, but the second time. It's continuously learning. But if you want to enumerate it, you can do that as well using restrict slot values and synonyms. You can have response cards as well, where you can ask bot to choose, where you can ask users to choose from. So once you have the utterances and slots here, you fulfill it with a Lambda function. In our case, I'm fulfilling it with a Lambda function. So we are calling a Lambda function, which is written in .NET Core. So let me just go through the code. So this is your Lambda function. And if you go to the NuGet packages, you can see here it has Lex events as one of the packages. So that's your package, NuGet package that you add to access all the Lex APIs. And this is your entry point into your Lambda function, your function handler. So your function handler gets triggered whenever order flowers chatbot utterance, something is uttered in that chatbot. And you double check it, OK, this is the intent this Lambda function is supposed to fulfill, so order flowers. And then you call the intent processor. So this is where all the work happens. So you process the intent over here. So you get all the slot values, and you validate those slot values. Like, did they give the right values or not? If not, then you send back. You can elicit a slot, and you can send back saying, OK, yeah, I don't have all the slot values. Can you fill in these values here? So once you have everything done, you're validated everything, all your values are right, and you're ready to fulfill the order, you can call in DynamoDB, or you can call in actual third-party vendor to get these flowers and make sure you book that. All those things can be done. And here we are just calculating a price based on the length of the string. So it's a super simple thing. It's not real. But in reality, you can actually do that. And once you have that, you can store your values in session attributes and send it back to the bot where you'll fulfill the task. So you'll delegate it, and then you close the task by putting it as fulfilled. And you send the message back telling, thanks for your order. It has been placed. And this is whatever you want to type in. You could type in that. And then once you have your Lambda function, you just right-click and publish to AWS Lambda. So that's it. Once you publish to AWS Lambda, you select the region, and function name and all those things and upload it. It gets uploaded into AWS. And once you upload it, you can start using your chatbot. So I've already given the fulfillment Lambda. I've chosen that Lambda function, and I've built this chatbot, so you can test it here. So I'm going to type, I screwed up. I think Lambda function's getting. So it will tell you what type of flowers would you like to order. So I can tell Rose. So it does not have roses in its list, right? So it's asking me, our most popular flowers are roses. So I can type in roses. So what day do you want? I could type tomorrow. So when you type in tomorrow, you could see the pickup date is filled in as the date, not tomorrow. It's actually converted into a date. And you can have pickup roses at what time? Noon. Okay, your roses will be ready for pickup by, and it will cost that $25. So that's the calculation I was talking about. In real time, you can actually call APIs and get the rate and then put it over here. So does it sound okay? Okay. Thanks for your order for roses has been placed and will be ready for pickup by 12 on this date. So that's Lex for you. So you saw how simple it was to build a chatbot, even though we didn't have the real-time APIs call in, but you could build these real complex chatbots as well with Lex, and all these APIs are at your disposal, and you can do it in .NET Core with Lambda functions.
Cool. So if you guys want to run that demo, there is the actual code there and actually a YouTube video walking you through it. So I'll give you guys all a chance to snap that if you want. OK. So the next thing we're going to talk about is Amazon Comprehend. It's all about text analytics. Now, you might be thinking, well, if I have text, don't I already have the data, right? Well, what if you wanted to uncover the underlying meaning of that text? Well, Comprehend can help you out there. Now, what Sri said earlier about NLP is hard and expensive, you could spend an entire lifetime trying to tune an NLP model to be really, really good. But is that the business you're in? Does that provide your customers better value of having your own custom algorithm? Or wouldn't you want to just use another model that maybe is easier, that doesn't require so much maintenance, that's constantly being tuned at AWS? And that's really where Comprehend comes into play. So you can discover insights and relationships in your text. So you can extract entities, people, places, things, key phrases. You can actually detect languages, sentiment analysis, and topic modeling. And the really interesting thing with that is sentiment analysis. So some machine-based open source stuff will tell you, yeah, it's positive or it's negative. We actually give you 4 scores. We give you positive, we give you negative, we give you neutral, we give you mixed. And we give you the percentages of what it inferred. So it might say, well, 25% of that was positive, and 10% was negative, and 65% was neutral. So you can actually mine your own data to figure out that metadata, and then maybe store it alongside of the data for searching or for analytics. You can also do things like topic modeling. So let's dig into a couple of those use cases in the enterprise. So with content personalization, you could use Comprehend to actually take a look at different documents, finding the entities, phrases, or topic similarities for trend analysis. So you could do content personalization. You can, again, store that alongside of the data that you already have and say, OK, well, this was about horses and that was about horses. Maybe they would like to see that content and recommend maybe that document, right? You can do what's called semantic searching, where you're searching based on intent, not necessarily exactly what is spelled out. So you can build an index around the objects that are extracted out and then cross-reference that index when you do the search and get more results, right? My favorite use case for this in the enterprise is intelligent data warehouse. And the reason why I say that is, if you look at where the really hidden gems inside your data is, especially in relational databases, it's at the end of the table. It's called notes. It's called reviews. and it's a varchar 5000 field with really great customer insights that it's painful to search, right? But what if you took that field and you did a sentiment analysis on it, and you did an entity analysis on it, and then merged that data back in with that same row and said, okay, here are the things that that person is bringing up in the review. Here's the positive ones, here's the negative ones, and then use analytics against that to say, okay, if we look at products that were bought and returned, how many of the reviews had a negative sentiment? Or when someone contacts a call center and you're transcribing notes, and you take the sentiment from the notes, how many of those are positive? What are negative? And what was the actual transaction type to help provide a better customer experience? Also, social analytics. That's what the demo is actually going to be. You can actually track how your brand, how your company, how your products and services are trending. So we're actually going to read in some tweets and then do some of this analysis. And then finally, information management. It's one of those topics where no one really likes to spend money on it. But if you have to do it, why not do it right? So you can go in, take a bunch of different pieces of text, documents, find common topics. You can run things maybe for compliance or IT processes to try and pull out that underlying meaning. Because the reality is, if you just have a folder full of documents, maybe they're named properly, but you don't know that it maybe contains information about how you're doing your PCI attestation, right? Or you're following some SARbox rule, right? And you wanted to find all those documents. Well, if the documents is called Standard Procedure 12572, you wouldn't know. But if you actually do analytics on the data, on the text, you might be able to pull that out. So this is what we've built. We're going to read the Twitter Stream API, push it into Kinesis Firehose, our streaming platform. It's going to go into Comprehend. It's going to do a sentiment analysis. It's going to do an entity analysis, push it back out to S3. With S3, we're going to go ahead and take Athena, which you can query flat files in real time, and then it's going to push it out to our BI platform, which is Amazon QuickSight. I know that sounds like a ton of technologies, right? But don't worry, it's not that hard. It's not that difficult. Again, Comprehend, like the other solutions, fully managed deep learning based. It's not machine based. It's not open source based. NuGet package for .NET, so it's easy to consume, pay-as-you-go, scalable, low-cost, a bunch of languages, a bunch of regions. So let's get right to the good stuff, the demo. So if we take a look at the actual code, what we're doing is we're getting tweets from the Twitter API. So I'm going to go in, I'm going to grab the JSON, and I'm going to convert it into an object. Then I'm going to make this translate request if the language isn't English. So the first thing I'm going to do is get the tweet in. Twitter tells us what language it's in. If it's not in English, I'm going to convert it to English. So you can see to convert that is about 10 lines of code to actually do the translation. Next, I'm going to do sentiment analysis. Here's the sentiment request and the call to detect the sentiment. That is 5 lines of code. It's that simple to infuse your .NET applications with deep learning. It's really that easy. I get the sentiment back. I go in. I store the text, the original text, the ID, that positive, negative, neutral, and mixed score. And then I push them back out on Kinesis. And then I do an entity extraction. So that's what this is. Again, about 5 lines of code to do entity extraction. And it's all, C#, object-oriented, dot operators, very easy to consume, very easy to use, hitting the back-end REST APIs at AWS. Now, the other really nice thing about this is you don't have to have a footprint on AWS to use any of this. You can use the public APIs that are secured with SSL and run this from any of your applications. As long as it can connect to the internet, you're good to go. You don't have to have EC2 or a VPC or any of this other stuff. You can actually start using this today, even if you don't have a footprint on AWS. All you need is an AWS account. So we're going to grab all the entities, and we're going to store that information and push it into Kinesis Firehose, which is going to put it into an S3 bucket for us. So this is the dashboard that I created. We're doing a flat file parsing with Athena. And I just went in and looked at the entities. So you can see I threw up a quick pie chart. So it has how all these different things are trending. The sentiment score, positive, negative, neutral. And then I put in the bottom the text, the language, and then the original text. So you can actually see like this bottom one converted from French to English. So here's the English, there's the French. And that doesn't take that long to do. We actually have the demo right here. So if you want to try the demo out, it'll take you about an hour to do that, and you can actually try it yourself. But even using all those managed services is very, very quick, and they all scale. Since they're all managed services, you don't have to worry about having to make a bigger S3 bucket or make a bigger Kinesis fire hose. It manages all that, throttles it up and down for you. Shri?
Thank you. So next is Amazon Translate. So what is Amazon Translate? It has it in its name. So it's basically neural machine translation that delivers like really good quality translation at affordable prices. So let's get some quick context around Translate, right? So according to CSA research, 55% of consumers buy only on sites in their own language. So, and that's significant. And it's super critical because your selling capability is limited to the languages that you support. And it's not just for selling, it's across board, like when you're talking to a customer center representative or you're having blog posts or reviews, people like to talk in their own language. And one of the interesting things is that this statistic stands true even when the translation is not perfect. So even it's almost over there, people like tend to buy stuff, tend to use these sites with blogs in their own language. So that's really important. And if you want to expand globally, localization is the key. But localization is not that easy, It's manually intensive. For example, if you're using translators, just imagine those translators translating your whole site and how much time it's going to take, and you're going to get a hefty bill after all that translation. So what organizations tend to do is they tend to translate only their core assets, their super important assets. Like if it's a retail site, only the product names probably, and not the reviews or the description of it. Or if it could be just their marketing items, marketing material, and not the complete thing. And at Amazon, we face the same issue. We had the same issue. So that's when Amazon decided to go the machine translation way. And since 2017, we've been using machine translation to translate all our product listings, descriptions, search queries. And we've been translating like hundreds of billions of words every year. So our product documentation, vendor and seller support reports, all those things are translated using machine translation. And what makes Amazon Translate so successful, right? Amazon Translate shines when there is like large volume of data. And when you have like high volume of data, like reviews, blog posts, you just put it into Amazon Translate, and it translates that and gives back you the result. And also, if you have like a data which is quickly getting created and deprecated quickly, for example, live streaming. So something is getting live streamed, a video, you can have transcribe, give you the captions, and translate it real time. So you can do that real-time translation of those videos using Amazon Translate. And also, you can use Translate like along with human translation. For example, you have like some super critical document that needs to have certain kind of style. It needs to be perfectly translated. That's when you will probably use a human translator, right? So while using human translator, you can use Amazon Translate to give you the first draft of it. So it could translate first and give it to the human translator, who can then go through the document and improve the accuracy and style of it. So you can use it along with human translation. And that's typically useful for regulatory filings and marketing materials and your UI. So what is at your disposal right now? So first, Amazon Translate supports translating between 54 languages. Last week, we released added all these additional languages, and it It quickly translates your sentences. On an average, it takes only 500 milliseconds to translate a sentence. And you can just give a plain text to it, and it will translate. You need not even tell what language it is in. It will detect that, and it will translate. And as I said, native language detection, where you need not give the original language or the language of your text. Why customers prefer Amazon Translate? According to Ofer Shoshan, the CEO of 1 Hour Translation, they were able to reduce 67% of their turnaround time with high quality. So they were able to reduce the cost and the turnaround time with Amazon Translate. And it delivers best return on ROI. So at $15 per million characters, you get the state-of-the-art quality translation. So that's really amazing, and you can integrate it with various AWS services like S3 bucket. And again, it's continuously learning, right? So you need not upgrade or update anything. So all these neural network AI services. And the pace of innovation at AWS is mind-boggling. You guys are witnessing it at reInvent. So it's amazing. So if you have any feedback for any of our services, you can just give it to us. Most of our roadmap is driven by your feedback. Again, as all other services, it's a fully managed deep learning system, and you can use a NuGet package in your .NET application. And Amazon Translate service supports 2,804 translation combinations. That's like English to Chinese, English to French, or something like that. So we support 2,804 translation combinations, and it's available in most of our regions. I'll quickly talk about Poly, and then I'll demonstrate both Poly and Translate together. So what's Poly? Poly is our text-to-lifelike speech service. So for example, you give a text to Poly in one of the specified languages that it supports. It converts that into it converts it into a voice. It enunciates in one of the 59 voices that we have. And it gets it right with respect to grammar, with respect to punctuation, with respect to pronunciation. And punctuation saves lives. You must have heard that, right? So it's basically, it gets the punctuation right, and it's the difference between having a robot speak to you versus a human, actually like a human-like voice speaking back to you. As I said, it offers 59 lifelike voices across 29 languages. And it, again, it provides low latency responses, so you can use it in real time. You can pair it with Lex, where Poly will give you back the responses in real time. And you can store, once the sound file is generated, you can store, and you can replay it as many times as you want. You're not going to get charged. So let's look at the quality of Amazon Poly, right? It's sounds lifelike. It sounds like human-like, and here is an example of that.
I get very tired of sitting by her sister on the bank.
So you heard that. It was almost like, a person speaking back to you. It was able to punctuate properly. It was able to, stress certain words. So that's Amazon Poly for you, and it interprets all these common text formats, such as abbreviations. So in this sentence, today in Las Vegas, Nevada, it's, I think, 60-degree F, but just take it as 90-degree F. Poly is going to change it to Fahrenheit. So
Nevada, it's 90 degrees Fahrenheit.
So that's Poly for you, where it converts all these abbreviations, where it expands that. And it also detects homographs. So in this sentence, there is, we live for music, live from Madison Garden. So Poly is going to detect that live and live difference. I hope you guys are able to hear in your mics this thing. Okay. So that's again, it detects homographs. And most interesting thing is it's highly intelligible. So you can have Poly tell all these, enunciate all these tongue twisters as many times as you want. So it will get it right every single time. So you can have all these tongue twisters, and Poly is going to enunciate that.
Picked a peck of pickled peppers.
So that's Poly, and it's, as you can see, we support almost all regions, and the orange thing in that map is all the regions where Poly has its voices and different languages it can speak in. So according to Duolingo, which is a language learning app, right? So their CTO said that with Amazon Poly, they were able to produce the most human-like text-to-speech voices available on the market. And that's a pretty great endorsement. So like all other services, Poly is again fully managed. You have a NuGet package and scales, pay as you go, same things. And it's available in almost all regions. Let's quickly move on to the demo. Thank you. So first, I'm going to show how Translate works and then Poly. So this is a simple console.NET Core application. And first, let's translate. And for translating, I'm going to use this sentence, which Thor loves. Las Vegas is the only place I know where money really talks. It says goodbye. And we're going to translate it in different languages, Swedish, Danish, German, French. And to translate that, we call translate, convert from English. And you can see here, we have a translate client. And then we provide the language code, source language code, and the target language code. You need not even provide the source language code. Translate is going to detect that, and it's going to convert that into a text and put it on the screen. And similarly, we are going to use Poly to say it. So first, we translate it, and we give that translation as input to Poly. And Poly is going to synthesize that text to speech, and you provide a voice ID. So every voice has its ID, and you can go and check on a product description page what IDs are for what voice, what languages. You can choose that, and Poly is going to say that. So same thing, all those translations, Poly is going to say it loud. So I'm just going to run this demo. So get ready to say Las Vegas is the only place I know where
Las
money
Vegas
talks.
to jedyne
This is what
miejsce,
translation
w
does,
którym
so it
naprawdę
translated
rozmawiają
in
pieniądze.
multiple
Mówi,
languages.
żegnaj.
And you can see here,
Las
it gets
Vegas es
translation
el
right with
liknande
goodbyes
único
really
lugar que
right.
conozco donde el liknande dinero realmente
Because
habla.
it is on
Adiós.
Wi-Fi, it's a little bit slow.
Las Vegas ist der einzige Ort, an dem ich weiß, wo Geld wirklich redet. Auf Wiedersehen.
And you guys were able to hear it
Las
when Poly
Vegas
said
est le
in
seul
different
endroit où
languages,
l'argent
right?
parle vraiment.
So you
Au
can see how it
revoir.
gets the goodbye right, and you can also see that we had a dash in our sentence, right? It did not say that dash while speaking back to you. Poly recognized that it did not say that dash, so it recognizes all those punctuations and everything. So that's Translate and Poly for you, and these are all the services that we have for you today. And I think we are moving to a place where we are humanizing technology, where we need not put all that hard work to understand technology. Instead, technology has started to understand us, right? And that's pretty awesome. So I'm more excited to learn about these services, how you can use them, explore them, and use it in your applications. And I hope you guys are excited too. And if you want to have a hands-on experience, we have a workshop with all these services tomorrow. You could come over there and bring your laptop and get all these demos working in your laptop. Thank you for joining us today. Thank you for listening to us. And please do not forget to fill the survey app.
Thank you.
Thank you.